3.4, number 7. And he desires to make a rectangular pasture for the animals to graze in. No two different kinds of animals. He's got 4 different kinds, can graze together. So in order to do that, he needs to use some amount of fencing she will need. She will decide to enclose a large rectangle divided into 4 equally sized pens. So a large rectangle divided into 4 equally sized pens. She decides to get 7,500 feet. What is it, feet? I'm checking here. Feet of fencing. So this is what we got to work with, and we want to make the maximum possible area. So since we're trying to get the area maximized, might as well make that easy. So I'll put X here and Y here. So the area would be X times Y. Now we've got too many variables, so we got to find out some way to control that, and we should probably use the fencing. So we're going to have to do 1, 2, 3, 4, 5 X's plus Y and Y plus 2 Y's to equal the 7,500 feet of fencing. So now we solve for either X or Y to get one of them out of there. Probably solving for Y is a little bit easier than solving for X, but it's not much different. So I'll subtract 5X from both sides. And then divide by 2. And I'll put that in for the Y. And take it, and then I have to take X times it, so it's going to be 3750 X minus 2.5X squared. So the derivative would be 3750 minus 2 times that would be 5X. And so if I set this equal to 0, the 5X is going to have to equal, gives me 5X is going to have to equal to 3750. So divide by 5, and X would equal 72550. And this is in feet. So that's this measurement, 750 feet. And my Y, I got the Y right here. So that would be 3750 minus 2.5 times 750. 2 times it would be 1,500 plus 375. I better do this correctly. I'll check, make sure I do it right. So 2.5 times 750 is 1875. Subtract those. And I get 1875. What's the maximum possible area of each of the 4 pens that each of the 4 pens will enclose? So if each one's equal in size, and this whole length is 1875 feet, the total area will be, I could divide this by 4 and take it times 750, or I can multiply these and divide the answer by 750. So I'm going to take this times 750 divided by 4. And each pen will be 3, 5, 1, 5, 6, 2 square feet, which differs from what the book had. So the book answer is incorrect on this particular problem. Okay, number 8. So this one we have 2 vertical poles, 60 feet and 80 feet, stand on level ground that are 100 feet apart. So if this is 100 feet, here's my 60-foot pole, and here's my 80-foot pole. And if I'm going to attach a cable that is stretched from the top of one to the ground and to the top of the other, what is the minimum possible length of the cable? So I'm going to minimize this here. Now, I could make this X, but that makes it kind of complicated. So I'm going to put X here. So this side is 100 minus X. And now the length of the cable here would be, the Pythagorean theorem, which says it will be 60 squared plus X squared square root, plus the length here would be 80 squared plus 100 minus X squared square root. So there's the length of the cable. To minimize it, I'm going to have to take the derivative. So L prime. So this is like the half power, so it's going to be 1/2 everything inside to the negative 1/2 times the derivative of the inside, which is 2x, plus 1/2 for the square root power times everything inside to the negative 1/2 times the derivative of the inside. So the derivative of that is -1, and the derivative of that is times 100 minus X, 2 times 100 times this to the 1. So there's the derivative. And that's pretty messy. Not going to clean up very well, so I'm just going to type that into my calculator and find out when that's equal to 0. And that's a lot to type in, but bear with me here. First of all, let's cancel the half with the 2, this half with this -2, and so I have square root of 60 squared plus X squared and that should be 1 over that. So instead of doing square root, I'm going to go parenthesis, close parenthesis to the -0.5 times X. So that's the first part. Plus, now this second part. So I got parenthesis 80 squared plus parenthesis 100 minus x quantity squared, and that whole expression, square root to the negative, times a negative, parenthesis, negative, parenthesis, 100 minus x. Okay. So now I can push graph, and I want to know when it's 0. Looks like it's creeping up slowly, so I'm going to have to go out there a long ways. Let's see. X has got to be somewhere between 0 and 100, so I'm going to put in my window 0 to 100. And looks like it crosses somewhere in here, so I'm going to go second, calculate the 0 that's between there and there, and it's about there, and it tells me it's at 42.857. That's X. But they didn't want us to find X. They wanted to find us the length of the cable. So I've got to put that in for my X's in that original equation. So to do that, I'm going to go up here, and I'll just turn this one off, and I'll come down here, and I'm going to type in the square root of 60 squared plus x squared plus square root of 80 squared plus parenthesis 100 minus x close parenthesis squared. And that's the length. And so I'm going to go to the table and find out what it is when x is 42.857. And it says it's 172.05. Okay? So we relied on the calculator quite a bit on that one. All right. Now we're to the propane tank problem, number 9. And the tank is a cylindrical tank with hemispherical ends. So cylindrical looks something like this. I'm assuming this is a tank laying on its side on the ground, but it could be standing up. With hemispherical ends. So these are hemispheres here and here. And it wants the tank to hold 1,000 feet cubed. And the ends are more expensive. They cost $5 per square foot. And the barrel costs $2 per square foot. And we want to use calculus to determine the minimum cost to construct the tank. So now we're doing a cost function. We've got assigned variables, so I'm just going to call the radius R, the length L. So if I have a hemisphere on this end and a hemisphere on the other end, the two hemispheres would go together to make a full sphere. And the surface area of a sphere is 4 pi r squared. So that would be, and that's the only measurement. And we have r as our radius, and so we're going to set the the cost of the ends, the more expensive one, is going to be $5 times 4 pi r squared. There's the cost of the ends, plus $2 times the area of the sides. And if I take a tank and slice it up the side and lay it out, it's a rectangle. And the distance around will be 2 pi r, circumference of the circle, and the height is L. So the area is 2 pi r L. And here's the $2 and the $5. So there's the cost. And we want to minimize, so we're going to take the derivative. But first, let's clean this up a little bit. And we're going to get 20 pi r squared plus 4 pi r L. Well, since I have r and L, I'm going to have to solve to get rid of one of those variables. Well, I haven't used this 1,000 cubic feet yet, so I need to use that. Now, the volume of this tank is going to be a sphere, 4/3 pi r cubed, plus the cylinder, which is pi r squared, area of the base, times the height. And that's supposed to equal 1,000. So I think I can solve for L in this and get the L out of this equation. So L would equal, if I subtract that, I'm going to get 1,000 minus 4/3 pi r cubed, subtracting that from 1,000, and then dividing by pi r squared. So my cost is going to be 20 pi r squared minus plus 4 pi r times L, which is 1,000 minus 4/3 pi r cubed divided by pi r squared. Well, let's see if I can simplify this part a little bit. Derivative of that would be easy. This part, this r would cancel one of these r's. This pi would cancel the pi. And so I'm going to get 20 pi r squared plus 4 times 1,000, 4,000 divided by an r, so that would be r to the minus 1, minus 4 times 4/3 is 16/3 pi, and this is r cubed divided by r would be r squared. So, minimizing the cost, I'm going to take the derivative. So that would be 40 pi r. Derivative of this would be minus 4,000 r to the minus 2 minus, and 2 times this would be 32/3 pi r. And I want to set this equal to 0. That may not be so easy just to do looking at, so let's just go to the calculator and let it help us out here. So we want to do 40 pi x minus 4,000 x to the minus 2 minus 32 pi x divided by 3. And zoom 6. Now, R is the radius, and I got a 1,000-gallon tank, so R is going to be somewhere not too awfully terribly big. Looks like it's about 3 point something. And that's a reasonable answer for this. Radius of 3, diameter 6, about the height of a person. So let's find that 0. So I can calculate the 0 between, see, that's between 3 and 4, so I'm just going to type 3, 4, and I think it's 3.5, and it says no, it's 3.514. Okay, well that's the radius, and that would be in, what was this tank measured in? Feet, but we want the cost. So we can put that, we can solve for R here, or we can just plug R into, this is before we took the derivative, and that was the simplest. We can just plug R into that. So go to my y equals, turn that one off, come down and put in 20 pi x, 20 pi x squared plus 4,000 divided by x minus 16 pi x squared divided by 3. And then I can go to the second table and put in 3.514, and it says the cost will be $1,707.30. Okay.